Namaste, all of you. Namaste, everyone, and myself, Xiisci Takalakar, for your friendly teacher. Dear friends, I wish you have a revised day today. I mean, you have to revise your work, your good habits, your good work per day, per week, per month, per years in your life. Okay. Dear friends, percentage packing fraction. You know, the atoms or ions, they are spherical in shape, and therefore there is percent packing. Some empty spaces remains there during the packing of the in a crystalline substances, and those are called as a heights. And because of heights, the percentage efficiency is not 100%. Okay, and the reason for this is that the spherical shape of the atoms or ions. Okay, so here we are going to determine the percentage efficiency in the case of some of the unit cells. For example, the simple cubic cell or some body centered cubic cell. One can write BCC, body centered cubic cell, or some face centered cubic cell, and the hexagonal closed pack cell. Okay, so here let us consider during the determination you must know the Z. So what is Z? We are going to calculate. That is the rank. This is the rank of each type. Again, the relation between R and, so R is the radius of atom or ion, and A is the unit cell age length. Okay, and then the percentage packing, that is the percentage efficiency. Let us consider, if you consider the react, so what is react? So react can be multiplied as that is the atoms or ions per unit cell. Okay, now we are going to study first. Then also the packing percentage packing fraction can be determined as the fraction that is occupied by the atoms. So here the volume of all atoms or ions, whatever are there in a unit cell, and the volume of unit cell. Okay. So here the volume of, this is nothing but the volume of one atom multiplied by the number of atoms. Okay, number of atoms in unit cell. That is nothing but cell. Okay, divided by the value of the unit cell. Okay, or one can this volume of one atom, and the atoms are spherical. Therefore, the volume of sphere 4/3 pi r cube, and the Z divided by the volume of the. So unit cells there may be a, we are going to study that is a cubic cell. Okay, it may be a simple or BCC or FCC, as well as hexagonal closed pack cell. So in this case, the volume of this cube is given by A cube, whereas for the SCP, the base area into the height. Okay. So consider this right here percentage packing fraction is equal to directly 4/3 per r cube into Z upon the value of the unit cell. Okay. then consider the rank. How the ranks for different ellipses. Consider, suppose this is the cubical one cell, right? So here, if you consider just like this, there are 8 vertices, and at the 8 vertices there are 8 atoms or ions. Generally the anions are there, which are larger in size. Anions are at 8 vertices, and as you know, if this is the 1, 2, 3 and the 4, okay, 4. Now this is the common, this vertices is common to 4. Similarly, in this layer also 1, now 5, 6 or 7. Okay, so these vertices is common to the 8 others, all others. Okay, so here, therefore one can write the contribution. This is common to 8. Therefore its contribution is 1 upon 8 every times 1 upon 8, 1 upon 8. So here the contribution of every vertices, every atoms here is 1 upon 8. So here the one can write rank determination, contribution. Okay. Suppose that this is a simple unit cell, cubic, or BCC or FCC. Okay. So here and HC. Okay. Contribution from the vertices or vertices, that is corner atoms, or body center, or face, and total, that is J. Consider. So here, as you know, there are 8 vertices and the contribution is 1 upon 8. So this is the 1. There are no any atoms or ions in a simple group, body center or F center. This is simple one. Okay. So here there is a total net. Even though there are 8 vertices, 8 atoms are there, but the net or effective atoms or ions are only 1. Now the body center. At the center, here there are atoms or ion in the cube. So there is 8 into 1 upon 8, and there is a 1 from the body. There is no 2. Now, if you consider FCC, face centered cube, then this is the face. There are total 4 and 5 and 6 faces, and every face at the center of face there is a 1 atom or ion here. Okay, like this. 1, 2, 3, 4, 5, 6. So here there are 6 faces, and each face is common to other, like a wall of the room. Okay. So here there is 8 into 1 upon 8 equal to 1. As well as at the body there is no any atom, but there are 6 faces, and the contribution is only half. Therefore this is equal to 3, and total becomes 4. Okay. Now consider hexagonal close packing. Like this. So here there are 6 atoms. As well as there are the like this NAP types. Okay. And it is put on the length. So there are, now you are going to observe triangular heights are there. Okay, there are 6 in numbers. So this can be put like this. Okay, like this, or like this, or like this. Okay, so only 3 are completely closed. Formation of tetrahedral heights are taking place. Okay, and the octahedral heights are taking place alternatively. 3 tetrahedral and 3 octahedral heights are there. Okay. Now, if you put the next layer on the here, so this is the height centrally, and the central atom of this layer is exactly on this depression. So this is nothing but the A layer, this is the B layer, and this is exactly above all these 6 layers. So this is the A, and this is also A. these are similar in the when you stacking. So this is A layer, B layer, A layer, B layer, A layer. So ABAB pattern is formed. This is a SCP type of the if, and if this second layer is put on the first one, and the third layer is been put on the tetrahedral wise. Okay. When the third layer is put on the tetrahedral wise, then ABAB type of the pattern taking place, and there will be now consider this is cell. So in the body there are three, right? There are three atoms or ions. There are three in body. Similarly, and there are how many vertices are there? These are the 6 vertices. These are 6. There are 12 vertices. 12 vertices. And each vertices is common to the 6th one. Okay. This is are the corners. So this is the 2. Okay. And again, in this case, as you observe, at the above face top, there is a 1 atom, and below there is a 1 atom. Okay. Or ion. So here one can show here, this is like this and this. Okay. Like this. Okay. Or like this. So here this phase contribution are 2, and each is common to. So 1 is the contribution, it becomes 6. So we can write here the for simple there is only 1 Z, that is the ranking Z. There are 2, there are 4, 6. Okay. Now we are going to consider the volume of unit cell. So in this case, the volume of unit cell is of course for the cubic cell there is a cube, whereas for the SCP, and this is the cube cell, for the SCP it will be the area of the base into height. Okay. Let us determine the area and the height first. Okay. Consider the hexagonal close stack like this. Again, then so here, as discussed, if you consider the center of this atom, and if you attach this, there are formation of equilateral triangles. 6 equilateral triangles are formed. Okay. Okay. Consider this is the hexagon, like this. Okay. Like this. Okay. At the center, there are also 1. This is the 1, 2, and 6 numbers of. So this is the A, like this also, and in between this, as per discussed here, the like this. Okay, A B A. So here, right? The suppose this is the one of the holes. There is a tetrahedral. This is again alternative tetrahedral lines is there. Here again tetrahedral line is there. Suppose T1, T2, T. Here there is a octahedral line O1. Okay. Octahedral line O2 and octahedral line O3. Okay. Okay. Now exactly the center of this there will be 1. Exactly the center of this here 2, and exactly the center of this. Okay. Okay. So here it will be tetrahedral, octahedral, tetrahedral, alternate, and therefore here these are the 2 center, and this is the 1 here. Okay, right here. one can join here also, forming a triangle like this. Now here, if you, this is the center of this pipe. This is like this. Okay. This is the bottom. This is the here like this. Okay. And this is the height. The third layer like this. Like this. Okay. Okay. Then this is suppose half the distance. This is suppose the x. Okay. And suppose this is the B1. This is suppose B2. This is suppose B3. This is x. This is also x. So one can. This is the height of the this pencil, and this is nothing but the x. Okay. This is again x. So x is equal to 2x. Okay, x plus x. Okay, we are going to determine this height as well as the area, base area. Now suppose consider one of the triangle. This is the equilateral triangle. Equilateral triangle. Okay. So the area for the equilateral triangle is given by square root of 3 by 4 side square. Or this can be 3 by 4. So what is the side? So here, if you consider this hexagon, so there is a sphere, okay, in this, and this is a sphere. So this is the two spheres. So this is like this, like this. So this is the center, this is the radius. So here, point is the r. So here, square root 3, 2 square, it is a 4 getting cancelled, and this is the square root of 3 and r square. Okay. Now, area total is equal to, there are 6 triangles, 3 arcs. Okay. So here in this case, for the 6 total area for 6 triangles, 1, 2, 3, 4, 5, 6. Okay. For 6 triangles. Okay. Equilateral triangles. Okay. Now consider the height. How you determine the height? If you consider the these are the centers of this. One can forming a triangle, equilateral triangle. This is the center of height. This is the radius of this anion, because anions are larger in size. Okay. And if you, this is the, suppose this is the one of the, okay. So here, this is the, you can join this also. So this is nothing but, if you, this is the one of the rectangle triangle, this. Okay. So here, here there is the anion like this. Okay. This is the height. So here, suppose this is the y, and this is the x as denoted here. This is the x. Okay. So this is nothing but the like this, and this is the form this one. Okay. So here the 60 degree. 60. These are 60 degree, and this is 30 degree. 30. So here cos of 30 is equal to this r upon this y, or square root 3 upon 2 is equal to r upon y, or this y is equal to r square. Okay. Now if you take into consideration this, so here again one can consider the this panel. This is also 90 degree. Okay. This is the cos 30. This is also 30. This is the y. Okay. Now consider this x and this is r as of this other this square here. So this is suppose a 1. Okay. This is the b1. This is the b2. This is the b. Okay. Now as you know, x square plus y square equal to this x square, right, plus y square. This is right angle triangle. Okay, right angle triangle. That means like this. The one of the square like this. So here right angle triangle. Okay. Now here it is a right angle triangle. Okay. And this right plane. Then this x square, right? This x square and this y square is equal to twice r square. Okay. So x square is equal to twice r square. Or x square is equal to twice r square minus y square. Or this is twice minus this y, that is twice r upon 3. So this is equal to 4r square minus this 4r square upon 3. Or this is 12r square and minus the 4r square upon 3. Now this is a 8 upon 3r square. Or x is equal to, therefore x is equal to square root of 8 by 3r. Okay, 8 by 3r. Okay, this is a 8 by 3r. Okay, now this x, and therefore h is equal to 2x is equal to the 8 by 3 r, this r square. Here, therefore, this can be further simplified. 2 into 4 into 2 by 3, okay, upon 3, and this is a r. This is equal to, come out the bracket. This can be the 2 into 2 upon 3. Okay. Therefore, finally, the value of this value can be calculated as the area of the base into height. Okay, area of the base, and the basic area is 6 into 3 into r square multiplied the height, that is this height is 8 upon 2. Okay, here 8 upon 3, and this is the r. Okay, consider now. Consider. So that we find the value of unit cell is equal to, set to be the 6 into 12. This is can be used. It is found to be 24 square root 2r. Dear friends, here this is for the hexagonal closure, where the value of unit cell is equal to the area of base into height, and 6 is equal to area of base is given as the 6 times 3. Okay, r square into height is given here twice 8 by 3. Okay. So here the base area here is given like this, and finally one can find here the 24 2r, and therefore the percentage pairing fraction is equal to 4 by 3 pi r cube into z, and that is z is equal to 6 divided by the base area, right? Area into height, and that is area is 24 square root of 2 r cube. So this getting cancels. Okay. Again, one can find that the percentage taking fraction is equal to 74%. Okay. So one can eliminate and derive by substituting the values. Okay. Now what is about the now consider some more details. Dear friends, this is very important how the SCP is made. This is the first layer. There are triangular heights. When you put a second layer, now carefully observe the three heights are completely closed and three heights are partially closed. The completely closed heights they are tetrahedroids and partly closed heights they are as a octahedroids. Okay. Now when the third layer is put on the tetrahedroid, then the SCP pattern is formed. Now, like this or this, okay, either one, like this or like this or like this, okay. So here one can put the third layer on the tetrahedroid, the AB type, that is the geometry forms, okay. SCP type hexagonal closed pack is formed. And if the third layer is put on the octahedroids means here the partly closed heights. Then the CCP type cubic closed packed structure is formed. Okay. Now consider. Consider cubic, this is the cube, okay, this is the cube. Now I discuss here what is the relation between the radius and A. Now here is a one atom or ion. Generally the bigger size ions, if there is ionic compounds, bigger size ion, that is anions are bigger in size than the cations. They are here. So here this is the one of the say the ion, or here is one ion. So this is the twice R. A is equal to R. A is equal to twice. Now if you consider the BCC at the center, now let us consider this is the here is one, and here is one. Okay. At the center of this body. Okay. This is the one. Okay. Here is one and here is one. So this is the right angle triangle here. Again this is the right angle triangle. Then one can consider like this. This is the R. Here again, if you like R. 4 R is this one. This is the A. This is again A. This is again A. So this is again one of the right angle triangle like this. So here this is nothing but the square root 2A. Okay. And this is nothing but 4R is equal to square root 3A for this BCC type. So here we can write here 4R is equal to square root 3A, or A is equal to 4R square. Now if you consider FCC, so suppose this is the face, there is this atom here and here, and if you consider this cube, okay, so here this is the one, and this is the third, and if you consider this triangle, this is the R, and this R, so 4R is equal to, this is the A and this is the only A. So here the twice A. Okay. So here one can write 4R is equal to square root of twice A, or A is equal to 4 upon square root 2. Okay. Now the values here, percentage fraction or simple cube is equal to 4/3 pi r2 into 1 divided by volume of unit cell, that is A cube, and A cube, that is the twice R, and this is found to be 52%, 0.3%. Okay. If you consider what is the second fraction for this 2 is equal to 4 by 3 for R2, and Z that is 2 for the BCC and AK, where A is equal to 4R square root 3 cube, and this is said to be the 68%. Okay. And the percentage taking fraction for this is 4 by 3 for R2 into Z is 4 for the FCC. The A is equal to 4 R square root 2R. Okay. R cube, and this is going to be 7. From this it is clear that the packing fraction in the FCC type or SCP type are same, 74%, and as well as it is the maximum packing efficiency of crystalline solids. Okay. With this, we are going to study a very important point which is connected to the bodies, different types of the bodies. Okay. Very important types of points. What are points? Those are the empty space formed because of the spherical shape of the ions when the stacking taking place in a crystalline solids. So here also, when any unit cell taking place, formation of unit cell, that is the basic fundamental unit cell, that is the building unit cell in a crystalline solids. So here the packing type, that is a linear packing, where the anions and coordination number of each is 2, and here the empty space, that is the coordination number of the anion is equal to 2. Okay. Generally these are unstable because the radius ratio of this is very small, 0 to 0.155. Okay. So here the cation can be escaped, very small, and therefore it can be escaped from the. Now consider the here also the cation is also the coordination number of the anion. What is coordination number? Coordination number is the number of nearest atoms or ions. Okay. Atoms or ions. Okay. So here in the planar packing, there are two types. One is like this. Okay. So here this is the second type, where 1, 2. In the depression of these two, there is a like this. In the depression of this, okay, like this. So here if you consider 1, 2, 3, 4, 5, 6. Okay. The coordination number of anion is equal to 6, and coordination number of cations. The cations occupy the triangular hole here. So here is only 3, coordination number is 3, like this, and the anion is the M larger in size. These are the small. What are smaller? Cations are smaller. Okay, small size. Okay. If you consider this here, the coordination number of the anions, the larger or atoms maybe. So here it is the, if you consider this one surrounded by 1, 2, 3 and 4. Okay. So here it is 4, and coordination number of the cation smaller in size. So there is a height like this. So here the cation, okay, positively charged and it is surrounded in also 4. So here there are 4, but here 6 and plus 3 coordination numbers. Now consider the packing in 3-dimensional. There are again 2 types. One is the suppose A type. So here consider this type like this, 1/1. So here the coordination number of this may be to its forms. If you consider this one, so there is a 1. If you consider this one, suppose like this. Okay, this is the bottom. Now this is the second layer. So here this is 1/1. Okay, so any this is surrounded in one plate by 4. Okay, this is a 4 in layer, one above and one below. Okay, so here there is a coordination number 6 for the atom or the anion. That is the larger ion. Okay, in this case. Okay, so here if you consider the cube form, the white form here inside, one can observe here there are 8. These are the 4 and these are the 4. Okay, these are 4 and these are 4s. Okay, so here at the center the coordination number of the cation in height. What type of the cubic height is equal to 8. Okay, so this is the difference. Okay, now consider the second type. AB type. That means if you consider the like this 1, 2, 3, 4, 5. So every atom is in the depression of others. Okay, suppose this is a one row. In between these two, this is the one. In between these two, this is the one. Like this. Okay. So in this case, if the second layer is placed on the first layer, then there is a formation of 2 types of the hives. Okay, 2 types of the hives. And in this case, then one can write here the AB type on second layer stacking 2 hives for. Okay, those are the tetrahedral and octahedral. Okay, like this. So octahedral is, so in one plane and in second plane there will be like this. So there is a octahedral. Okay, and here in one plane there are like this, and then the one on the tetrahedral, this is the one square is there. So here, if the third layer is placed on the tetrahedral or octahedral, then the AB type, that is the SCP type, the flexiforms of third layer then placed on the octahedral height. Then what happens? The ABC type, that is the Xiisci type forms. Now in this case, if you consider the below central atom or ion surrounded by 6, so in one plane there are in plane, and if you put one layer here, so again that atom is surrounded by 3 in above and 3 in below. So total there will be 12. So coordination number is equal to 12 for the many atoms or anions or atoms. Okay, main side, main side, main side. But what is about the एक अगले 7-8 मिनट लगा किंवा 5 मिनिट काय प्रॉब्लेम नाही किंवा मी बंद करेन. Okay. So here AB type of the packing is forms. So in this case, the what is the height like this here? If you consider the height here, okay. Suppose this is the plane and this is one. So in between these 3 and this 4, there is a height that is the tetrahedral height, and this is a smaller height. Okay, and smaller height. So here the coordination number of cation is equal to 4. Okay. Now what is about the here? If you consider this arrangement, the coordination number of the height cations is equal to 6, and the main side and coordination number of main atom, that is the main side atoms or anions, that is the larger in size, they are of course the above layer 4, in layer 6 and layer 12. Okay, coordination number equal to 12. Similar to this 12 and 12, but the coordination number of the height is 6 here, and the coordination number of the cations, that is the height for height. Okay, in height. Okay, so here one can distinguish the tetrahedral heights and octahedral heights like this. If you consider tetrahedral heights versus octahedral heights. Okay, larger of course smaller. Okay, larger in size, like this. Okay, or this is the in one plane and there is a one square along this. So here coordination number of cation inside in height is equal to 4, and here it will be here plus. Okay, here plus. Okay, so here 4, here it will be 6. Okay, so here the position where they occur, position they are again they are along the body diagonals. Very important, diagonals. Each diagonal has 2 heights, tetrahedral heights. Of course, tetrahedral heights. Here are same. So here, if you consider then the cube, then there are 4 diagonals. Okay, into the 8 heights are there, equal to 8 heights. Okay, equal to 8 heights. Whereas if you consider the hexagon. Okay, so here one can consider the. Okay, then there are the 6 diagonals. Into 2, there are 12 tetrahedral heights. Okay, on body diagonals only. And if you consider the position of the position of octahedral the heights. They are first one in body center and along edge center. Center. Each edge. If you consider them the cube, like cube, then how many? If you consider there is a body center, there is only one. Okay, so here is a 1 plus the how many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here the 12 edges, and in this case each edge is common to 4. So here 1 plus, okay, 12 edges. These are edges, and this is the common to 4. Common to 4. So here 3, 4. So here for n atoms, there will be n octahedral. If there are 4 atoms, then there will be 4 heights. Of course, octahedral. If you consider the types at the body center, in body there are 18 such edges, and each edge is common to 6. So there will be 6. So here total 6 octahedral heights are there. Okay, octahedral heights are there. So for n there will be n heights, n atoms. For n atoms there will be n heights. Dear friends, we are going to stop here today. Thank you very much.